This process is going on everywhere else in our galaxy. Every star, every planet in the galaxy is also being bombarded by these cosmic rays, which, if they make black holes when you have a collision like this, certainly should have happened already. People say that, in fact, if you think of all the particle collisions that will happen in the LHC during its maybe 20-year lifetime, our galaxy has already conducted 10 to the 31 of those LHC experiments already, and it's 10 to the 13th of them are happening every second. And we don't see giant explosions happening in the galaxy that often. We do see supernova. That's like 1 or 2 per century, not, all the time, which is what it would certainly have to be if we're creating those.
So the energies of cosmic rays that come from somewhere in the universe, relative to the energies of the protons at the LHC, are much, much higher. So cosmic rays have vastly higher energies than the LHC energies. They collide with atmospheric particles, which are practically at rest. So they have little energy compared to the LHC energy, but the combination is enough to produce black holes if they were there. If they were there, it would be enough to produce black holes. If the LHC can produce black holes, then cosmic ray collisions can produce black holes easily. And the fact that such collisions have been happening throughout the universe for the whole history of the universe, yet they haven't destroyed the Earth or any other planet or any, is a direct indication that we don't have to worry about.
These particles can have phenomenally high energies, much, much higher energy than the particles that we send whizzing around the LHC, by many orders of magnitude. And so when these particles hit the gas nuclei, the nuclei of gas atoms in our atmosphere, they create huge showers of particles which eventually make it down to Earth. And this is happening all the time. In fact, if you hold out your hand, there's 1 cosmic ray muon per minute per square centimeter going through every portion of your hand all the time. If you could see these cosmic rays, they're just raining down in this room right now. They're everywhere.
So in order to draw the analogy between the LHC, where both 2 very energetic particles are colliding with each other, and the collisions of cosmic rays with the atmosphere, where a very energetic cosmic ray collides with a particle essentially at rest, an atmospheric particle, you have to be very careful. You have to compute the total amount of available energy in the so-called center of mass frame. And when I tell you that there is a direct analogy between LHC collisions and atmospheric collisions with cosmic rays, I already take that into account. I go to the center of mass frame where you can compare apples with apples. And that is where the center of mass energies, that is the amount of energy that's available to create black holes, in collisions of energetic cosmic rays with atmospheric particles can be far greater, 10 times greater than LHC energies. So, and even there, even in spite of that, there hasn't happened any catastrophic event involving black holes to destroy the Earth or any other part of our universe.